Hello and welcome back to Newton's Bench, and this is lab number 4. This is on ramp physics and friction. So if you remember from the lectures, we have the free fall equation, which is simply if we assume that we're just dropping something, we have no initial velocity, the height, the change in displacement from the place where we drop it to the floor, we can get from 1/2 AP squared, where A is 9.8 meters per second squared. If we assume that this height is a positive number. But when the object is going down the ramp, it's not going that full acceleration, is it? That acceleration, if it was going straight up and down, it would be just G, and we would get the force of gravity being mg. But it's not, it's at an angle. So that angle dilutes the acceleration down this ramp, how fast it's going down the ramp. And we can get that by using sine of the angle for that dilution. So in this case, let's say the angle is 42.5 degrees. The acceleration down this ramp would be 9.8 times sine of 42.5 degrees. Make sure your calculator is in degree mode. But in the real world, we also have friction that is keeping us from going down the ramp. Okay? It's keeping us from going down with an acceleration of g times sine of the angle. Well, how do we calculate the acceleration due to friction, or I should say the deceleration? We know that with certain materials, whatever the ramp might be, whatever is sliding on it, the two materials together, we have something called a coefficient of friction. We're going to use the U lowercase k for that. And so we know that the force of friction is equal to the coefficient of friction times normal, where the n is the normal force. In this case, it's going to be diluted by the angle as well. The force of the friction opposite of the acceleration down the ramp, and if we say F equal ma, the acceleration up the ramp is just g times cosine of the angle times the coefficient of friction. So if we have the force going down the ramp as mg sine of the angle, and the force going up the ramp, or holding it back, is the coefficient of friction times mg cosine of the angle, where g is equal to 9.8 meters per second squared, and uk is the coefficient of friction between the ramp and the marble. Since F equal ma, we could cancel the m out of each of these. And that leaves us with the net acceleration down the ramp. So if there's an acceleration down this ramp, we subtract out the deceleration that is holding it back, the friction that is decelerating it, and that will give us the net acceleration, which is g times sine of the angle minus coefficient of friction times g times cosine of the angle. So now finally, with that, we could get to our experiment. So we're going to use the ramp as set up as like so in your kit. You want to set it at the lowest level with just one of these large spacers. Use 2 hooks with the mast in the base and with this hanger here. And you're going to need to measure the length of the ramp from where you let go to how long it is. And we're going to put this on here, and we're going to let it go, and we're going to time it, how long it takes to do that. We want to repeat that 5 times at least to get an average T. We know at the top of the ramp the velocity initial is 0, because I am not pushing it down the ramp, I have it held there. The change in distance, we measured it, right? And the acceleration net would depend upon the angle of this ramp. So you would use your protractor to measure the angle of this ramp. Well, if we plug in these pieces of information here into this third equation, we only have one unknown here, and that would be specifically the coefficient of kinetic friction. You would be coming up with, by experiment, the coefficient of kinetic friction between the marble and this plastic ramp. So, in conclusion, using the ramp, you're to calculate the coefficient of friction between the marble and the ramp. Again, we have an acceleration down the ramp of g times sine of the angle. We have a deceleration caused by friction of g times cosine of the angle times the coefficient of kinetic friction. And those net out for the A we're supposed to use to get the coefficient of friction down this ramp. Save that coefficient number. You're going to be needing it in another lab. Make sure you fill out your methodology section completely. It needs to be detailed. Again, if there's details left out, we're not to assume you know exactly how you did the experiment. Don't forget a picture or two. Please show all your work. Good luck.